So this is notes 5, page 4. Rule of thumb here. When simplifying expressions, unless you're directed otherwise, we're going to write our final answer without negative exponents. There will be times when I say just go ahead and leave the negative exponents, because there are times when negative exponents are just easier to deal with. But most of the time, we want them out of the problem. So what we want to do is really sort of start practicing with quickly removing negative exponents from the form of our answer. So let's consider x to the negative first over 3 to the negative first. One thing that's really important, this is of course one term overall, but moreover, there is only one term in the numerator, and there is only one term in the denominator. That will make this, that basically means there's a real shortcut for getting this. Now, the way I'm going to do this the first time is like the longest way around, but we're going to see if we can pick up the shortcut. So, when you take reciprocals, you take them in relationship to where they are. X to the negative first is the term in the numerator. So the reciprocal will be the term in the numerator, 1 over x. 3 to the negative first is the term that's in the denominator. So when you take the reciprocal will be the term that's in the denominator. Okay. Now, it's been a while probably since you've done compound fractions, but just remember this fraction bar is really just a division bar. So this is the same as 1 over x divided by 1/3. And then remember, in some of the preview notes, like notes A maybe, we remembered, oh, you know what? The way we divide fractions is to avoid it altogether. We don't divide. We change this to multiplication by the reciprocal. So I take the reciprocal of what I was going to divide by. And then for multiplication, you just multiply across the numerators, across the denominators. This is 3 over x. Okay. So, do you see a potential shortcut? Yes, there is. But this shortcut only works if you have one term in both the numerator and denominator. If that happens, what you can do, when you remove negative exponents, and what I'm going at here is when you remove negative exponents, I don't mean just erase the negative. Oh, I got rid of it that way. We're really removing the negative exponents by taking the reciprocal. That's how you get rid of a negative exponent, is by doing what it says to do. Take the reciprocal of the base. Just like, how do you get rid of the square? You actually do what the square says. Square of the base is 9, okay? So the shortcut is this. So here's the shortcut. Factors in the denominator move, see where the 3 used to be in the denominator? When you take it, it moved up to the numerator. Move to the numerator. And factors in the numerator move to the denominator. But those are factors, let me add it here, factors with negative exponents. That's what would cause you to move a factor from a numerator to a denominator. The x started in the numerator, it wound up in the denominator. And think about it. When you flip a fraction, numerators become denominators. The 3 as a factor started in the denominator, it wound up in the numerator. And again, when you flip a fraction, denominators become numerators. But this only works for factors of the entire numerator, and of course factors with negative exponents. So let's practice this shortcut. So we're going to remove negative exponents by actually taking the reciprocal. We're just going to take the reciprocal in a very shortcut way instead of the very long-winded way I did initially. So look at this fraction. Observe. The numerator is all one term, the denominator is all one term. So this is a factor with a negative exponent. And you can actually think of this as 1 times y to the negative third. So this is a factor with a negative exponent. So what this says, and generally I draw the fraction bar first and lay things out in the numerator and denominator where they belong. All right, the 3 to the negative second, that's a factor of the numerator. It's going to go down to the denominator as 3 squared. Notice, when I took the reciprocal, I did what the negative exponent told me to do, so I've used it up. Just like over here, when I squared the 3, I did what the exponent told me to do, so I used it up. The answer is 9, not 9 squared. I haven't squared the 3 yet. So the 2 is still hanging around. I still have to do that. So I just dealt with the negative exponent by flipping that down to the bottom. The x in the numerator does not have a negative exponent. It stays on top. Then the y to the negative third, the negative says take the reciprocal of that base, which means move it up to the top, but I haven't cubed it yet, so the cube's hanging around. So once I take the reciprocal, I've sort of done what the negative exponent tells me to do. I've used it. It's gone. One last thing I need to do is go ahead and square that 3 now, and so this is x y cubed over 9. Okay. Now, I want you to notice here, this can also be written with a 1 in front of it here. So this is also 1/9 of an xy cubed kind of guy. So the type of term it is an xy cubed, and you have 1/9 of them. That's the coefficient of that term. So that's important to know. But note, where did the 1/9 come from? It came from 3 to the negative second. 3 to the negative second is 1/9. It is not -9, and that is the most common mistake. This negative does not mean the opposite, it means the reciprocal because the negative is in the exponent. Okay. You try problem B. Pause the video, give it a shot, try simplifying the expression, and your answer should have no negative exponents. I'm going to go ahead and go over it. The first thing I'm going to observe, this is all one term. Oh, I'm just getting tired, huh? All one term in the numerator and in the denominator. These are factors. These are factors. So if I have all factors in the numerator, all factors in the denominator, I can use the shortcut. Otherwise, I can't use it. So notice again what I do. I draw my fraction bar first. So I can lay things out in the numerator or in the denominator, wherever they belong. Careful. That's the opposite of 5. It is not the reciprocal of 5. There is nothing that tells me to flip that. That's -5. X to the negative seventh. That says take the reciprocal of that. So as long as you have factors, if the factor's in the numerator, you can flip that factor down to the bottom, but the 7th power, we haven't taken that, so that hangs around. So this is x to the 7th in the denominator. The y to the 1st, well, there's no negative exponent there, so it's hanging out in the numerator. Okay, now I look at the factors in the denominator. The x to the negative 2nd, well, that says take the reciprocal. And since that factor's in the denominator, when I take the reciprocal, it will move to the numerator. So I've used the negative part of the exponent. I did what that said, but I haven't done anything with the square, so that stays. The y to the negative 5th, again, that says, hey, take the reciprocal, so that flips up to the top as y to the 5th. You are not done yet. You have removed the negative exponents, making it somewhat easier, but notice the same base shows up in the same one term. Got y's in the same term, I got x's in the same term. That means I can simplify some more. The first thing I'm going to notice is, why should I write y to the first times y to the fifth when that is just y to the sixth? And then I'm going to notice, oh, I could cancel 2 of these x's with 2 of these in the bottom, leaving me x to the fifth in the bottom. And that is as simple as you can write that term. Okay, one last problem. There is something different about this problem. Take a look at it. What is significantly different about this problem? It's this big fat plus sign. There are 2 terms in the numerator, which basically means no shortcut. No shortcut. So I have to go back and do things the same way I did them before. And what was that? And if you remember, when we looked at the very first problem before we knew the shortcut, we said, hey, if this term is in the numerator, its reciprocal will be in the numerator. If this term starts in the denominator, its reciprocal will be in the denominator. So these terms are in the numerator. Their reciprocals will be in the numerator. And sometimes I'll do things like this. I'll make a triangle around this one, a square around this one. It's supposed to be a square, and a circle around this one. So the reciprocals, oops, I did that backwards. So I'll make this the square. It's terrible. Okay. The reciprocals go in the same relative position in the fraction. So 2 to the negative first, the reciprocal of 2 is 1/2, plus the reciprocal of 3 is 1/3. Those both stay in the numerator. So the term started in the numerator, the reciprocal stays in the numerator. X to the negative first, it starts in the denominator, its reciprocal stays in the denominator. That's what happens when you don't have all factors in your numerator and denominator. And then we have to deal with this. It's really not that bad. Remember, a fraction bar is like parentheses, so it's this answer divided by this answer. And I'm going to not have a lot of space, so I'm going to do some things in my head. 1/2 plus 1/3, the LCD is 6. Multiply this by 3/3, so that's 3/6 plus. The LCD is 6, so I need to multiply this by 2/2, so that's 2/6 divided by 1/x. And so in the numerator, now that I have a common denominator, that's 5/6. And then I'm going to change the division symbol to this. 5/6 divided by 1/x. Instead of the fraction bar, I have that division symbol. Because this prompts me, this division symbol, just from basic math, reminds me, oh, I'm not going to divide. I'm going to multiply by the reciprocal. So that's 5/6 times x over 1. And so this nasty expression is 5/6 of an x, or you can write it as 5x over 6. No matter how you express this, if I should ask you, what's the coefficient of this term? It is 5/6. So if you write it this way, you have to realize the 6 is part of the coefficient. So that's 5/6 of an x. That's the end of this video.